Hello everyone, welcome to my YouTube channel. So this video is for NEET 2021, some of the important points of the chapter haloalkanes and the haloarenes. Okay, so in this video I'll going to cover some important points. Okay, this is the first part of haloalkanes and the haloarenes, and in another video I'll going to complete the another part. Okay, so these points you have to remember. I know you will going to read the theory, okay, but some points you have to concentrate on or on more where you may get the questions. Okay, so with that regard, here are some points. So the first point is like as you all know, haloalkanes and the haloarenes represented by the general formula Rx. Okay, this R when it comes to haloalkanes, hydrocarbon, haloarenes, this R is nothing but you will going to have a benzene ring. Okay, so what is the general formula of a haloalkanes? We have CnH2n plus 1 X. So this is the general formula you have to remember. Now, how you can prepare the haloalkanes? So there is a plenty of methods available for the preparation of a haloalkanes, or you can call it as a alkyl halide as well, right? So you know the methods, you have learned the theory, you have gone through the like all the method of preparation, but some points you have to remember within those methods of preparation that I'll going to give here. So from alkanes you can prepare. So when alkanes is undergo halogenation either in presence of a UV light or by maintaining a temperature around 250 to 400 degrees Celsius, it will going to give the alkyl halide and the hydrogen halide. Okay, so there is another process of preparation of haloalkanes, that too particularly the alkyl chloride. Okay, so that is chloroalkane you can prepare. That is when alcohol is treated with a HCl in presence of anhydrous zinc chloride. To here is okay, anhydrous zinc chloride, it gives respect to the alkyl chloride. That process is known as what, dear students? Gruss process. The name of the process is Gruss process. Very important. Okay, here the primary and the secondary alcohol can be quantitatively converted. Means, so here alcohol, primary alcohol and the secondary alcohol can be treated with a HCl in presence of anhydrous zinc chloride, and that gives the respective alkyl chloride. Okay, but if we are using a tertiary alcohol, no need of anhydrous zinc chloride over here. Okay, that's a point you have to remember. Now, what is the role of anhydrous zinc chloride? Why we are using anhydrous zinc chloride here? See, this will going to act as a Lewis acid. So some people will call it as a Lewis acid. Okay, I'm going to pronounce it as a Lewis acid. Anhydrous zinc chloride acts as a Lewis acid. You may get a question based on this one. Okay, so what is the role that we are using over here? Here, it coordinates with the oxygen atom of alcohol. Here it tried to weakens the bond of a carbon and oxygen. Okay, so just see here, it coordinates with the oxygen atom of alcohol. As a result, the CO bond weakens. That is, a carbon and oxygen bond will get weak. Okay, and chloride readily attacks the carbon atom to form a alkyl chloride. Okay, that is the main role of a anhydrous zinc chloride. It will going to break the bond of CO and it will going to make a new bond of CCl. Okay, remember that point, very important. Now, the reactivity of a hydrogen halides towards reaction is, so HI is highly reactive, followed by HBr, followed by HCl. Okay, and the reactivity of alcohol follows the order: tertiary is highly reactive always, followed by secondary, followed by primary. Okay, so those order you have to remember, dear students. Now, so there is a plenty of methods are available for the preparation of alkyl halide, as I told. Okay, that one method is by using when an alcohol is treated with a respective phosphorus pentahalides or phosphorus trihalide, like phosphorus pentahalide or phosphorus trihalide, we will going to get a respective what I can say, alkyl halide. In that case, PBr3, phosphorus pentabromide, phosphorus pentahydride are highly unstable compounds. Why they are unstable compounds? Because of the steric hindrance. Okay, therefore only the alkyl chlorides are obtained with the PCl5. Okay, that you have to remember. Now, next point, we have a alkene, means we can prepare the alkyl halide by using a alkene and by treating with a hydrogen bromide. Okay, so this is very important. So this is hydrohalogenation of a alkene in absence of a peroxide, in presence of a peroxide. This is very important. When a alkene, which alkene? Unsymmetric alkene. What is unsymmetric alkene? On either side of the double bond we are getting a different number of carbon atom. Okay, so this is unsymmetric alkene. When treated with a hydrogen bromide in the absence of a peroxide, I'll going to get secondary product. Means the bromide, the negative part of the adding molecule, will attach to the carbon containing least number of hydrogen atom. So this is what Markovnikov's rule. Okay, so means the hydrohalogenation of an unsymmetric alkene in the absence of a peroxide follows Markovnikov's rule. Same unsymmetric alkene, when treated with a hydrogen bromide in presence of a peroxide, gives the primary substituted. Okay, means it will go against the Markovnikov's rule. Means what? During the hydrohalogenation, the negative part of the adding molecule will attach to the carbon containing more number of hydrogen atom. So it is against the what I can say, Markovnikov's rule. So it's an anti-Markovnikov's rule. Presence of peroxide, anti-Markovnikov's rule. Absence of a peroxide, Markovnikov's rule. Okay, and this presence of a peroxide is known as the Karash effect, or you can call it as a peroxide effect. Okay, very important, dear students. Based on this one, you will going to get a question. Now come to the next one. Alkyl chloride, when treated with a sodium iodide in presence of acetone, gives alkyl iodide with sodium chloride. Okay, so this reaction is known as a Finkelstein reaction. And similarly, when methyl chloride is treated with a respective metallic fluoride, here we have taken a mercuric fluoride particularly. Okay, you can use a silver fluoride over here, antimony fluoride over here. Okay, so metallic fluoride when treated with a respective alkyl chloride, here I have taken particularly methyl chloride, you will going to get respective methyl fluoride. This is called Schwarz reaction. Okay, now there comes another reaction, Borodine-Hunsaker reaction. Okay, here we have a silver salts of a carboxylic acid when treated with a bromine in presence of a solvent carbon tetrachloride, we will going to get methyl bromide, silver bromide and carbon dioxide. Which mechanism it will going to follow? It will going to follow free radical mechanism. They may ask you question like this. Borodine-Hunsaker reaction going to follow which mechanism? It will going to follow free radical mechanism. Okay. So now, when it comes to some physical properties of haloalkanes, melting point and boiling point. Greater the molecular mass, stronger. See, as the molecular mass increases, as the carbon atom increases, stronger van der Waals force of attraction increases, and hence higher will be the boiling point. Okay. So now, for same alkyl group, see here we have a same alkyl group, but only the halide is changing, the halogen is changing. Okay, so in such cases, how will going to arrange the boiling point? Boiling point decreases as the atomic mass of the halogen decreases. Means between the iodine, bromine, chlorine, fluorine, iodine will be having a, what I can say, a more atomic number and the more atomic mass. Okay, so for the same alkyl group, boiling point decreases as the atomic mass of the halogen decreases. Okay, this is the order. Now, among dichlorobenzene, okay, now I am discussing here about the haloarene. This is very important. You have got the question many times based on this one. The para isomer being symmetrical packs closely in crystal lattice and has a higher lattice energy and hence much higher melting point than ortho and meta isomer. Okay, so like this. Okay, ortho, meta. Okay, when it comes to a para, among all these three dichlorobenzene, this will be having a higher melting point or the boiling point. Why? Because of the symmetrical packed closely in a crystal's lattice, means there is a symmetrical arrangement, okay, and it's a close packed structure, and it has got a highest lattice energy. More the lattice energy, more energies means what? More energy is required to break a bond, that's it, okay, and higher will be the melting point, okay. Now let us move to the SN1 reaction. So I'll do one thing. Let us go with the SN1 reaction. So SN1 reaction, what do you mean by SN1 reaction? Unimolecular nucleophilic substitution reaction. Okay, so here what happens, the substitution of a nucleophile will takes place. We have a tertiary alkyl halide, okay. So here what happens, the formation of a carbocation takes place, the breaking of a CX bond takes place, that leads to the formation of a carbocation. That carbocation, okay, will get attacked by the nucleophile, okay, that is called nucleophilic substitution, and forms a stable compound. Here the step 1, that is the formation of a carbocation, is always the slowest step of the reaction. As we all know, slowest step is the rate determining step, right? So this step is important to find out the speed of the reaction. So this reaction involves only the alkyl halide. There is no participation of a nucleophile here, okay. So that's why rate of a reaction depends only on the concentration of a alkyl halide, dear students. So that's why what you have learnt in the chemical kinetics, that it's a first order reaction, means the rate of a reaction depends only on the concentration of a one reactant, okay. And the SN1 reaction involves the formation of a racemic mixture, that is the enantiomers will be formed over here. And the order of reactivity, tertiary followed by secondary followed by primary. So these are the some important points. Many more points I'll definitely discuss in the next class. Okay, so this is a little information about part 1 of the haloalkanes and the haloarenes. Okay, and the part 2 I'll going to upload in my next video. Okay, I hope these points may help you people. Okay, thank you.